We're solving a trig equation of the quadratic type. So when we look at this particular example that we have here, it tells us that we're working on an interval of 0 to 2 pi, meaning we're approaching 2 pi because of this parenthesis says we're not equaling it. But the bracket says here we can equal 0. Now let's look at this. I have sine, cosine, plus cosine, and sine again. So this is telling me that I'm working with the sign of alpha plus or minus beta, and this plus sign tells me it's a plus. We have this variable term x here, so we're going to put it on the end of this parentheses here. Now let's acknowledge, what is alpha? Alpha is 2. Beta is 1 here, right? Because the coefficient on x is. And if you have forgotten, we can just rewrite the identity out right quick. And I'm going to put x here because that's what they have. So we got sine of alpha, and let me clean this up right quick. Give myself some room. Sine of alpha, cosine of beta. And we put x on there since that we're working in the variable term of x, plus cosine of alpha x. Handwriting's getting a little messy here. Let's clean that up. Cosine of alpha x, sine of beta x. And again, I'm just going to write up here what these are. Well, knowing what alpha and beta is, I can say, oh, okay. So I'm going to plug it in. 2 plus 1 x gives me sine 3x. So what we know now, what we're working with as far as this goes here. Now let's go back to this other part of the equation, this equal to. It says it's equal to the square root of 2 halves, right? So when I go to the unit circle, I'm going to look at, because we're working in the identity of sign, let's go everywhere is on the unit circle that we see a positive, because if you notice this is positive square root of 2 halves. I see that I get a solution of pi fourths, and I'm going to keep looking, and where else do I see it? I get 3 pi fourths. Now, there is a square root of 2 halves in quadrant 3 and 4, but remember that's where our sign values are negative, so this kind of stops us from that point. Okay, so now that I have these values, I know what these are from the unit circle. Now I need to figure out the rest of these that falls within the interval, okay? So if I say that I'm solving for this, I'm going to go x is equal to pi fourths plus, I'm going to do my 2k pi. Because remember, sine and cosine works in the value of 2 pi. If it was tangent or cotangent, it would just be pi. So let's solve for this. Well, what do we know? Let's let k equal 0. When we do that, we start back at the pi equals 4. So now let's plug in when k equals 1. So that gives me pi fourths plus 2 pi. I'm going to put 1 in the denominator. I know I need to multiply top and bottom by 4. So now I get 9 pi fourths. So I get the other value, 9 pi fourths. And then I can plug in another value for k. I can say k equals 2. And that'll probably be as high as I'm going to go for this one because I still got the 3 pi fourths to solve for. So when k equals 2, I get pi fourths plus 2 times that 2 pi over 2, or excuse me, over 1, because, you know, we haven't found the common denominator yet. You say over 1. And now I get 4 pi plus 4 pi over, oops, I jumped again, guys. Let's backtrack just a little bit. I need to clean my mess up. Let's clean this up just a little bit. So we know that k equals 0 gave me this. K equal 1 gives me this. Okay, and that's for pi fourths. Now we're plugging in k equals 2 right here. So let me scroll down just a little bit, give myself some room. So now I have pi fourths plus 4 pi over 1, and I'm going to multiply top and bottom by 4 because I want common denominator. So that gives me what, 17 pi fourths? Correct? So now I have this other value here, comma 17 pi fourths. Now let's find, now make sure we stay within that interval of 2 pi. If you're not sure, we're going to double check. 17 divided by 4 is 4.25. It actually exceeded it, so we're not using it, right? Make sure the 9/4 didn't exceed it. It did, so we couldn't really use that one because 9 divided by 4 gave me 2.25. It exceeded the 2 pi fourth, or 2 pi interval right here. You see that? So I'm just showing you how to find values, but we exceeded it. So we know that we're not going to use this one and this one because it's outside of it. So let's take the x equals 3 pi fourths and add 2k pi. And what do we get? If I plug in 0, I'll get 3 pi fourths. If I plug in 1, I get 3 pi fourths plus 2 pi. And again, we're going to multiply top and bottom by 4 because we need a common denominator. Now I have 3 pi plus 8 pi over 4. Gives me 11 pi. So let's double check to make sure it didn't go outside the 2 pi. So 11 divided by 4, it did. So we wouldn't use that value, but there will be a time that we would keep going until we get all the solutions within that interval. So this was the way of solving this.